Welcome to new session of the differential equation. In this session, we will discuss about the method of variation of parameters. Method of variation of parameters is actually an alternate method to solve linear first order ordinary differential equation. Linear first order ordinary differential equation. See, we know the linear first order ordinary differential equation as y double dash plus f of x into y is equal to r of x is the linear non-homogeneous first order ordinary differential equation. Say, corresponding to this differential equation, we will have a homogeneous differential equation y double dash plus f of x into y is equal to 0 is the homogeneous part of the homogeneous part of equation 1. Okay, is the homogeneous part of the equation 1. We suppose that v of x is the solution of 1. V of x is solution of 1. Okay, actually we found the v of x as the c raised to integral minus f of x dx is the solution. So, we already discussed it is that v of x is equal to is the solution e raised to minus integral f of x dx. Sorry, v of x is actually v of x is equal to c e raised to integral minus f of x dx. Okay. So, this is actually v of x is the solution of is the solution of 2 is the solution of 2. V of x is the solution of 2. So, this is actually the solution of the homogeneous part. Okay, that is the equation 2. So, actually we need to find the solution of 1. Actually, we need to find the solution of the non-homogeneous linear differential equation. So, we have to find a function. We have to find a function. We have to find a function we have to find a function u of x. We have to find a function u of x such that y of x is equal to u of x into v of x is the solution of such that y of x is equal to some u of x into v of x. U of x into v of x is a solution of our non-homogeneous linear differential equation y dash plus f of x into y is equal to r of x is a solution of y dash plus f of x into y is equal to r of x. That is the linear non-homogeneous first order differential equation. Okay. See, so our thought is that how can we find this equation? So, simply I would like to take this as y is equal to uv is a solution of 1. This is actually the non-homogeneous linear differential equation. Okay, fine. So, y dash is equal to, we can consider this as u as first function, v as the second function. So, y dash is equal to u v dash plus u dash v is there. Okay, fine. So, we can write this is u dash v is there. We can put in 1. So, we will have equation 1 becomes as equation 1 becomes as, okay, in equation 1, say we will have equation 1 y dash, that is equal to y dash u v dash plus u dash v, u v dash plus u dash v plus f of x into y, that is u v, f of x into u v is equal to r of x. Okay, fine. So, from here we will have, here we have u is common here, and here also we have u. So, we have u dash v, the second term is u dash v plus u into, we will have, sorry, u into, we will have here, see, u into v dash plus f of x into, sorry, f of x into v. Okay, from here we will have f of x into v is equal to r of x. Okay, r of x. Fine. Okay, from here we can say that v dash plus f of x into v. Come back to here. Here we have v is a solution of the homogeneous equation. That means v is a solution of the homogeneous equation 2. Since v is a solution of the homogeneous equation, we can say that this is v dash plus f v equal to 0. V dash plus f v is equal to 0. From here we can say that v dash plus f v is equal to 0. See, come to here, we have v dash plus f v. So, this is v dash plus f v, that will be equal to 0. So, from here we will have this is equal to u dash v is equal to r is there. So, from here we can say that this is equal to u dash v is equal to r by v, sorry, u dash is equal to r by v, u dash is equal to r divided by v is there. So, we can integrating both sides, therefore, we will have u dash, instead of u dash, u is equal to integral of r divided by v, that is r of x divided by v of x dx plus the constant of integration. By using this we can find the u. Okay, fine. So, finally, we can say that this is equal to, therefore, general solution of y dash plus f of x into y is equal to r of x, that is the non-homogeneous linear first order ordinary differential equation, is y of x is equal to u v, that is equal to v is actually we found v from there, that is equal to v is there, and this is equal to integral of r divided by v. So, v is actually the equation, this is v into integral of r divided by v dx plus c, sorry, dx plus c. Fine. So, v is actually, we know about v, actually we can find by v by using this formula, v is equal to c raised to integral minus f of x dx. We know about f of x is the coefficient function of y. So, by using this we can find the solution. So, actually dear students, how can we find solve by using method of variation of parameters? How can we find the solve the linear differential equation by method of variation of parameters? Steps to find linear ODE by method of variation of parameters, by MVP, by method of variation of parameters. Given differential equation is there. That given differential equation is y dash plus f of x into y is equal to r of x. That is the original non-homogeneous linear differential equation. So, then we will find the solution of the corresponding write the corresponding homogeneous write the corresponding homogeneous equation y dash plus f of x into y is equal to 0. Y dash plus f of x into y is equal to 0. We can find the solution by using the formula. Okay. So, in step 2 we evaluate, this is equation number 2, find the solution of equation number 2, that is the homogeneous part, by using the formula sorry, by using the formula y is equal to c e raised to minus integral f of x dx. This is actually, instead of y, this is that we considered as v of x. Okay. So, we replace here c by u of x. In step 3 we just replace c by u of x. Okay. So, we can find, therefore, y is equal to u of x into e raised to minus integral f of x dx is the solution of the non-homogeneous differential equation. Is the solution of non-homogeneous linear differential equation, and we will find u of x by using above discussed methods. Okay. We just see the steps. We have non-homogeneous linear differential equation is here, and also we can write the corresponding homogeneous equation. We can find the solution of homogeneous equation by using the formula v or y is equal to c raised to integral minus f of x dx, and we just replace this c by u, and we will have this formula is here from, and also we are able to find out the u of x by using the method that we discussed before. Okay, u is equal to r by integral of r divided by v into dx plus c. Okay, fine. We can just move to one question. Write down a question. The question number 1, it is that apply the method of variation of parameter. Apply the method of variation of parameters. Solve linear ordinary differential equation dy by dx minus y, dy by dx minus y, dy by dx minus y is equal to 3 e raised to x, is equal to 3 e raised to x. See, actually the question it is that dy by dx minus y is equal to 3 e raised to x is the question. This is equation number 1, linear differential equation. See, here we have f of x, from here we have f of x is equal to minus 1. Here we have r of x is equal to 3 e raised to x. R of x is equal to 3 e raised to x. So, my dear students, we can write the corresponding homogeneous equation. So, the corresponding homogeneous equation is corresponding homogeneous equation is what about the corresponding dy by dx minus y is equal to 0. Dy by dx minus y is equal to 0. Dy by dx minus y is equal to 0. Okay. From here it is understood it is that y is equal to c raised to minus f of x dx. Therefore, y is equal to c raised to minus f of x dx. That is equal to y is equal to c raised to minus integral of f of x minus minus 1 dx is there. Minus 1 dx is there. Okay. So, minus 1 is plus 1. Therefore, y is equal to c e raised to integral dx c e raised to x. Y is equal to c raised is the solution of homogeneous part. The solution of homogeneous part. It is a solution of the homogeneous part. So, we replace c is equal to u of x. Replace c by u of x. Okay, fine. So, from here we can write this as c raised to x is there. Therefore, y is equal to u of x, that is u e raised to x is solution of non-homogeneous equation 1, solution of 1. Okay, fine. So, we can apply there in equation. So, differentiate, we have dy by dx is equal to u into derivative of e raised to x is e raised to x and u dash du by dx into e raised to x is there. Okay, we can apply in equation or apply in differential equation 1. Apply in differential equation 1. Actually, the differential equation 1 is we have dy by dx minus y is equal to 3 e raised to x. Dy by dx minus y is equal to, that is dy by dx minus y is equal to 3 e raised to x is the differential equation 1. Okay, fine. This is our equation 1. Okay, fine. So, instead of dy by dx we can write this as, okay, fine. Therefore, we can write u e raised to x plus u dash e raised to x, and then minus y is actually u e raised to x, minus y is u e raised to x, okay, minus y is 3 e raised to x is there. So, finally, we will have is equal to 3 e raised to x is there. So, we can from here we are able to cancel u e raised to x and minus u e raised to x is there. Finally, we will have u dash e raised to x is equal to 3 e raised to x. Also, we are able to cancel e raised to x and e raised to x. Now, finally, we have u dash is actually du divided by dx is equal to 3, du by dx is equal to 3. integral we can take dx to here. Now, this is of the form method of variable separable method that we discussed very first time of the differential equation. That is the first method that we discussed to solve a differential equation. Linear that we discussed is a first method to solve first order ordinary differential equation. So, we can write du is equal to 3 dx, integrating both sides. Integrating both sides. Okay. Therefore, integral of du is equal to integral of 3 dx, that is equal to integral of 3 dx plus c. Therefore, u is equal to 3x plus c, that is we found u is equal to 3x plus c. Okay, fine. Therefore, y is equal to uv is a solution of given differential equation is a solution of the given differential equation dy by dx minus y is equal to 3 e raised to x, dy by dx minus y is equal to 3 e raised to x. That is we can say that y is equal to u, that is y is equal to 3x plus c into the v that we found from here. It is that instead of c we have u e raised to x is there, that is the y c e raised to x. Therefore, u is actually e raised to x. So, sorry, v is actually e raised to x. So, we can say that y is equal to 3x plus c into e raised to x is the required general solution, See, my dear students, this is actually the method that we used here. It is that according to the method of variation of parameters, we can find a differential equation, that is linear differential equation. We have a differential equation is there, y dash plus f of x into y is equal to r of x. We can find the solution of that differential equation, firstly finding the solution of the homogeneous differential equation, and after getting the homogeneous differential equation, solution of the homogeneous linear differential equation, we just replace this c by u of x, and we consider this as uv, and this uv we apply we will find y dash, and after we will apply the value of y and y dash into original equation, then we are able to find the u. We are able to find the function u, and by applying that we can find the solution. That is actually we have a differential equation. While evaluating this one, we understood it is that is linear, and from here we found it is that the f of x, the coefficient function is -1, and r of x is the non-homogeneous part is 3 e raised to x is there. So, we found homogeneous solution of the homogeneous part, that is c e raised to x. We just replace c by some u and have to find the value of u. So, we just evaluate dy by dx, and while after evaluating dy by dx, just apply the dy by dx and y to equation 1, and after applying that one we are able to find out the u. So, by integrating we can find out u, and we can evaluate uv. Here in this question we just did not mention v, but actually v it is the solution of the homogeneous part, that is actually e raised to x. So, that is the general solution of the given differential equation. Okay, my dear students, this is an alternate method to solve linear differential equation. Okay, I will give you some questions that you can do by using method of variation of parameters, and also if you are interested, you can do this this all the questions that we done before session. We already discussed 3 sessions before that. That also you are able to do by using method of variation of parameters. Okay, right, and solve by method of variation of parameters. The question number 1 is y dash minus y is equal to x, and the second one is x y dash minus 2y, x y dash minus 2y, x y dash minus 2y is equal to x raised to 4, sorry, x y dash minus 2y is equal to x raised to 4. Okay, fine. See, here have to divide all terms with x. So, we will have y dash minus 2 by x into y is equal to x cube is there. That also you can do by method of variation of parameters. Right, and one more question, y dash plus 2y, y dash plus 2y is equal to e raised to minus 2x, e raised to minus 2x. Dear students, you may do all these 3 questions by using the method of variation of parameters. That maybe will give you a very clear cut ideas about how can you solve a linear first order differential equation by using the method of variation of parameters. As I said you before itself, you can find many textbooks related to differential equation. There you can find many questions. Try to solve more questions related to by using the method of variation of parameters. Okay, thank you for watching this video. Continue your watching. Thank you very much.